morning, everyone. Today we are going to start with a session of SCILAB. In SCILAB, we will be covering the graphics in SCILAB, means the various plots and graphs which we can plot in SCILAB. So, as sir has already told you, SCILAB stands for Scientific Laboratory. As MATLAB stands for Laboratory, SCILAB stands for Scientific Laboratory, and it is same, or we can say it is an alternative to the uh, MATLAB. So this SCILAB, the difference between SCILAB and MATLAB is that SCILAB is an open source software. Means its source code is open to everybody. The user can download the code from the site scilab.org and can use the code and even modify the code and then upload it for the other users also. So let me just give the introduction how to download. Just go to the site scilab.org, go to the downloads tab, then click the version according to your operating system, and according to your operating system, Windows, Linux, you can download the appropriate version of the SCILAB. So now today, directly starting with the graphs. So it will be, can I ask the centers if they are having SCILAB on their laptops or PCs?
Good morning, ma'am.
Good
Still,
morning.
we don't have the SCILAB because we are not the SCILAB.
Means you are having an introduction of the SCILAB? Prior to,
Not too much, ma'am. We are already know about the MATLAB software. Not aware of this.
if
We
you
are
know the MATLAB, then SCILAB is totally same. Just
okay.
yeah, it is totally same to MATLAB. As I have already told, it is an open software. The
It's a
only
open source, right?
Yeah, it is an open software, so you can download it from this site. But I am telling you can note it down on the notepads, and then later on you can run your programs on the laptops or PCs after downloading the program. Right?
Definitely,
Yeah.
definitely.
Ma'am, may I ask one question?
Yes, please.
What is the basic difference between MATLAB and SCILAB?
The basic difference is that it is openly available to all the users. Because MATLAB we have to purchase the software, costing so high, but
No,
SCILAB,
no.
yeah,
Which software has good performance?
performance wise both are okay, because this SCILAB is being used by the researchers, by the industrialists also, for their making their programs and used in the applications. So software wise this is bit slow, and some keywords or some syntaxes are not there in SCILAB, but the advancement is going, means the more and more advanced versions are still coming in SCILAB. So it is, I can say it is at par with the MATLAB.
Okay.
Yeah. So as you can see on the window, we are seeing the SCILAB. I have opened the SCILAB. So it is you can see this is similar to the MATLAB. So you are seeing the this is SCILAB console, and this is the variable browser where you can see the various variables which are being used in your program, and this is the command history. I think it will be visible to everybody. This is the command history on the right bottom side, and these are the various files which can be opened and which are there in the SCILAB. So starting with the Sci notes, as in MATLAB there is an editor window. So it is named as SCILAB, Sci notes in SCILAB. So after opening, let us start with the simplest plot. As we know, everybody is will be from the, I think, electronics or mechanical or electrical departments. So these are the basic plots which are going to plot, and then we will advance with the more advanced versions of the plotting. So starting with the, as we know in MATLAB we also do CLC, means it is clear console, and then clear means it will be clearing all the variables which are being used in the in our program earlier, if there is any data in that variable, so that all will be cleared. Then x is equal to, we are writing it is starting from 0 is to 0.1 is to 2 into pi. So we are creating a variable x starting from 0 to 2 pi with a difference of 0.1, and then we are plot 2d x comma sine of x. We are just plotting, this is the first plot. Let us see. Let us name it as if it is visible to everybody. So if we run this plot, and before running we have to save it. Let's name it as so this is the plot we are getting. This is a sine wave, everybody is familiar with it. So we are plotting 2D. In MATLAB we are using only the keyword plot. So in SCILAB we are using plot 2D x comma sine x. So similarly in the same line we can plot more x comma sine x comma sine of 2x three into x. So all these three plots will be plotted simultaneously on the same graph. In the SCILAB, for commenting any line, we use these double slashes. Hmm. So, so you have to be careful about the spaces and the commas in the SCILAB while writing the codes. So as we can see, 3 into x, there is an error in 3 into x. So as side by side you can check the errors if there is any error is coming in the program. Why is it coming? So use the, yes, we can also use the keyword subplot. Subplot means we are dividing the plot window in many parts. If we are using 2, 2 means we are dividing the whole window in 4 parts, 2 rows and 2 columns, and plotting in the first one. So prior to this has to be written here. So this is x comma, we can write here it is 2 into x. Let us see. So this is where we are getting the plots. The earlier which I was using, there was coming some error, but that was the syntax we can use. Means we can write plot 2D and then we can do. I think here it is, we have to write plot 2D 2. Let us, if we want to comment the same many lines, then we can select those lines and then press Ctrl D. So all these lines will come under the comment. Some error is there. To uncomment, Control Shift D. Right. So there is also a command plot 2D 1. So you can see there is no difference, you can see by using the plot 2D 1. If we use plot 2D 2, there is a difference. Means you are plotting in a steps. Here you can see. When you use command plot 2D or plot 2D1, you get these the continuous lines which is being used, and here step by step you are being plotted. Similarly for the if you use 2D3, then these vertical lines will be coming in the graph. And there is also a 2D4. So arrows will be there in the graph. You can use here in this. So these arrows comes in the lines also. So this is the difference in plot 2D, 2D1 and 2D2, 2D4. So these are basically two-dimensional plot keywords. Starting with the next is the function plots, means here we are using this x and then x comma sin x. What happens if the function is given and it is given in a functions, because we are making a functions when we want to use that program iteratively, means again and again we are using those 4 to 5 lines in the main program. Then what we do, we make a function for that, name that function, then call that function in the main program. So similarly, if we want to plot a function, plot something using a function, then what we have to do, so there is a provision in Scilab. In MATLAB, what we do, we use a separate file for storing a function. But in Scilab, we can use a separate file for storing a function, and also we can use the means we can declare a function in the main program also by using the keyword DEFF. Pardon? Online books are, various online books are there, various tutorials are there. Yeah, very less books are on Scilab, but tutorials and books are there in the net also. Black hole mirror. इसमें तो सभी black ही किसको यहाँ तो सभी ब्लैक है। ये है फोन गोल्ड, यहाँ से क्या है? ठीक है, yes, what you will say. So lot of means study material is there on the net also on Scilab, and also there is a help command in Scilab also. So type help then keyword about which you want to get the information. So as we do in MATLAB, help then keyword plot, plot 2D, plot 3D. So this way we can learn also. So next we will be doing the plotting using the function. So if we are plotting it as x is equal to 1:5:100. I think this is clear to everybody. X is 1:5:2 means the x variable will be created with the data starting from 1 to 100 with a spacing of 5. Then let me erase it all. So here we can write, it is, we can get the size of this x. Now this command will return the size of the x in the terms of number of rows and number of columns. Actually now we are going to plot a function y is equal to 1/1 plus x square. We are having a function y is equal to 1/1 plus x square. So for that we just created the variable x, then starting with for I is equal to 1 to d. then y of I means now we have to calculate y for each value of x, that is equal to xi into, this is the function we are creating, absolute value of xi divided by 1 plus x square. Xi into absolute value of xi dot divided by 1 plus x square means each element of this dot divided by means each element of x will be divided by 1 plus x square. Then plot 2D x comma y. Then declaring a function DEFF. Earlier what I did, I wrote the function in using the for means loop. I put the function in the looping because I have to calculate the value of y for each value of x. Now I am declaring the function DEFF. So the syntax for it, write the keyword DEFF. In the single quote write y is equal to function x comma y, fx comma y, then comma. After that declare what is the function y is equal to x into absolute value of x divided by,
एक्सक्यूज मी मैम, सॉरी
yes,
मैम, थोड़ा सा सेटिंग्स में थोड़ी प्रॉब्लम आ रही है। लेफ्ट साइड का जो पोर्शन है वो कट रहा है, हमें प्रॉपर विजुलाइज नहीं हो रहा है। थोड़ा
okay,
सा अगर, हाँ, लेफ्ट साइड में शायद रेशियो में, एस्पेक्ट रेशियो में प्रॉब्लम है कुछ है।
Harjot, yes, now is it okay?
नहीं, थोड़ा सा और करें मैडम, नहीं अभी भी है, और कर दें, और कर दें, थोड़ा और करें, यस यस, हाँ बस, नाउ इट इज ऑल राइट, ओके, थैंक यू। और नवजोत, थोड़ा जो पिक्चर साइज वीडियो आ रहा है ना मैडम का, साइड में स्क्रीन चलाई है, वो भी टेक्स्ट के ऊपर आ रही है, मिनिमाइज कर दें या कैसे? हाँ बस, थैंक यू वेरी मच।
Now see what I have done. I have written the code for both the in both these styles. Mean I can plot either like by using this for function or by using this function declared in the main program only. So let me use this first. I have commented these 9th and 10th lines. I can use here 2D2. So this is the function. So this is the graph which I have plotted here using this function 2D2, or if you say 2D, you will get a simple plot like this. See. So first I have declared the variable x, then taking its dimension means how many elements are there in the x, so I have used this keyword size. Then for 4, 1 is to d, I is 1 is to d, so this y will be calculated, and then I have plotted this x and y. Now I am commenting all these lines and uncommenting this function. This is the function declaration in one line. Then use the syntax of the plot. Now it is f plot 2d. Now it is f is being used before the plot. And then x comma f. Yeah. This has to be in the single quotes only. See. So this is the same plot we are getting. I think it will be, this is the code and this is the graph, right? Using the function. And then on the plot, if we want to X label, Y label, whatever you want to give the labeling for it. Y label. This is x-axis and y-axis. Similarly, we can add the title also, right? So next we will be doing, is it clear to everybody? 3D plots. CLC, x is equal to -3 is to 0.2 is to 3. This is the function declaration. Then z is equal to x raised to power 4 minus y raised to power 4. Then y is equal to x. Then f plot. Similarly, as I earlier told, if we are using the function, then I have to write f plot 3D. X comma y comma f. If I will not be using the function, then I would have written x comma y comma z, right? This is the plot I am getting on the x-axis, y-axis and z-axis. I've already told you the subplot function, that you can divide the window in various parts and then plot the plots in it. Subplot 2D2, 2D3, you can exercise on this. Plot 2D2, 2D3, 2D4, and similarly on the 3D also. Next is the mesh plot.
मैडम इसमें आपने z क्यों लिया, xyz?
Z इसलिए नहीं लिया because I have declared the z in the function. When I am using the function, then I have to write f plot 3D x comma y comma f.
Okay.
If I have written like this, z is equal to, means this is the value of z we are calculating. If I am writing like this, right, then the syntax will be like this.
Okay, okay. Right, ma'am, right.
Okay. So next we will be starting with the mesh plots. X is equal to -1 is to 0.1 is to 1, right? Similarly, declaring y is equal to -1 is to 0.1 is to 1. Then x comma y. Now declaring the grids and the values in, it will be written as max grid, right? X comma y. Then z is equal to x square plus y square. Then mesh. Now here instead of plot we are using mesh. X comma y comma z. So x being declared y, then a grid is formed for x and y, and then the function is z is equal to x square plus y square. Do you know why we are using this dot? Because each element of x will be squared, right? So there is a difference between x square and x dot square.
Madam, repeat करें एक बार please. Why we put this dot?
Because there are so many elements in the x, right? So
Okay.
we want what we want that all the elements should be squared. So for that we are using dot square dot division like this. We do basically
Okay.
the function of dot means every element will be operated now.
Okay, okay, right.
So this is the graph you can see, right? So this is the mesh plot. Similarly, you can see this is x, y, and z grid is formed. This is the grid which is being formed on the x and y, and accordingly x is equal to y, as we have already told, means the same declaration is there for x and y, and then mesh keyword is there. Then whole x will be squared or some error will come, because then what will happen, only a single element will be there. Right? So you can try on this, then you will be able to know. Next is the There is also a command surf, SURF. And also we can color this, means the grid which you were seeing, that was in black and white. You can also color your plots also by using the style. By using the font size you can change the color also, as I'm going to see. So you can use Xset. Using the Xset, what you are doing, color map. Means now you are defining that you are setting for the colors. This is the declared color map in the library, jet color map. '64, right? This you can see. So I am using the command surf also. You can use mesh also, and then this colored mesh will be available to you. Clear? Next is the axis variations, means you can
मैडम ये डिफरेंट कलर्स क्या शो कर रहे हैं?
you are adding the colors to it, means no such information is there from the plot like this.
No, I mean this blue color, this represent what? And similarly this yellow.
No representation of colors like this, just a
Okay.
color is there. Coloring of the graph is there.
Okay, right.
So next we are moving towards the axis properties, right? Now what this command says, X variable is being created. Linspace means linearly spaced elements will be created. First is the X minimum value, then -2 to 6 values will be there, means X min -2, X max is 6, and the number of elements will be 51. So earlier what we were giving the distance or the space what we were requiring, 1 is 2.1. Now here no space is given, we are just giving the how many elements we are requiring. Then D is equal to and size of X. Then for I is equal to 1 is to D, y of I, y is equal to 1 upon 1 plus x square. There is also a command SCF 1, but it says set current figure 1, means now the plot window will be having a number 1. So here if you write 2, the plot figure will be having 2 numbers. Like this, if you are making the programs for so many 1 to 13, then you can give the plot numbers in each program differently, SCF 1, 2, 3, 4, like this. So a different plot window will be created. Plot 2D, then set GCA. Now this is used for making the handles. Now there is a something like handles, means we are making the handle for this plot command. Handles means now again and again we don't need to have write this plot this. If we want to change the properties, then only we can use the handle GCA from. If we write h is equal to GCA, means we are making h as the handle of the plot. In the same command we are using the grid also. Grid in double quotes, now A is equal to GCA. Now this handle, what I was told earlier, h is equal to GCA, if you are saying, means you are getting the current axis hold to this A. You are giving the hold to the A variable. So then you can directly A dot x under location is equal to origin. Then A dot location this is in double quote. Set. Actually I don't want to write further, but I'll then make it a comment. GCA comma data bounds in double quotes matrix -2, 6, comma let us run this program. See, here we are using same plot 2D. Now you are familiar with this x comma y, but the axes are being changed. If we want to learn, then go it step by step. Only then we will be able to see what happens with this command. So what I am doing, just plotting and then setting this GCA with the grid. Grid on is also a keyword is there in MATLAB and SCILAB also. If you write the grid on, means this grid will be visible in the plot. This is also the way you can write in setting. You are setting the grid and -1 to 1. Now you are here A is equal to GCA, means you are giving the handle of the plot the A, and then A is equal to X location equal to region A dot Y location, means now A dot X location means you are changing the X location of the A plot. Now A is representing what? A is representing the plot graph, what we are plotting. So that is equal to region, and then this is equal to this, and we are getting this. Now see, where is the origin now? Earlier, when you did A dot X location equal to origin, A dot Y location is to origin, means the X axis and Y axis की जो आपने lines plot की थी वो कहाँ से cross कर रही थी? Origin से. So now it is plotting, writing this syntax, you are getting the lines starting from the origin of both X axis and Y axis. Then this set GCA means what it is saying, that you are getting this matrix -2 -6. See, -2 -6. This is the X axis which you are getting. This is starting from -2 up to 6 with the 0.2 and 1.2. This is 0.2 on the Y axis and this is 1.2. -0.2 to 1.2 is going to be from the Y axis range, and the X axis range is from -2 to 6. So similarly you can declare like this also. Yes. -2 is the X minimum and 6 is the X maximum. Similarly, -0.2 is the Y minimum and 1.2 is the Y maximum. Right? Yes. Yes. Handle क्या हो गया कि you are now giving the responsibility or giving the control to that handle. Now you are using the just word keyword A. With this A, you are controlling the whole plot. Whole plot window you are giving. Similarly, there is also a function handle is also being created in the same way. This is the plot handle, means you can giving the control to a simple A, H. So this way you can now change the axis properties, change the color using this A like this. The handle is created in MATLAB also and in SCILAB also. Next is the simple plot. No need to do it. Now next is the semi-log graphs. I'm creating a variable iteration, iter, equals to linspace zero comma error is equal to 10 raised to power minus iteration, right? I'm creating this error. Set current figure you want to do or not. Then plot 2D. Double quote NL, comma, iteration, comma, error, comma. Now here I am giving the line color style equal to 2. So see, in the semi-log graph, what you are getting, you just created the iteration variable, error variable, and you put plot 2D and M. Now on the y-axis you are getting ticks in the form of 10 raised to power minus 10, 10 raised to power minus 9, like this. If you do here LL, earlier, note the syntax, plot 2D, earlier but we were doing plot 2D x comma y, comma style. What will happen? Let us see. This is the plot. This is the simple plot. Now what we are doing, in the double plot we are writing NL, then what we are getting, this. And if I am writing here double means log graph. Earlier I was using semi log graph, right, with the keyword NL. If I am using LL means log graph, then what I'll be getting, come, it is not coming. Okay, log will also come. Let us see. You can add titles to this, X title, Y title, and style 2, style 4. The color of the line will be changing, right? It should come. The syntax for the log graph is plot to the L is there, but why? I don't know why it is not coming here. Comma iterations, comma error, and style equal to 4 or 2 or 3, whatever you want to do. There is a problem in the declaration of x. 0, 6. I am just creating an index in, then ITR is equal to 10 raised to power minus index. So here what I am getting, this is the double log graph. If I am using here NL, some error is there. So likewise you can use log and semi-log graphs. Another creation of error is there, raised to power minus like this. So next, moving towards the histograms. So histograms, you can plot bar charts, pie charts, contours, polygons, like this. All these means similar to MATLAB, it is there. And the most prior advantage is that it is freely available. So for the histogram, D is equal to so this is the declaration of the variable D, which is containing the random numbers being created, first row and 10,000 columns. Normal means the numbers which will be being created will having the mean 0 and variance equal to 1. So you can also mean by deleting this normal, random numbers will be created, but the range of these random numbers will be between 0 and 1. So using this normal means now the mean of all these numbers will be equal to 0 and the variance equal to 1. Next is the Hist plot. For the plotting of the histogram, you are using the keyword Hist plot 20, D. This is the way histogram is being created. Now 20 means these 20 bar graphs or 20 locations will be there. 20 bars will be there. If you use here 10, see the difference, right? So 20 and D. Similarly, you can write like this also. Hist plot if I am writing here only, comma, you can add the legend by using the keyword leg, legend, equal to single quote, whatever you want to give, rank. Then you can also write comma style comma just this only. Let us see. So this way, this legend, as you can see here, this legend is being created, ran, and the color of the graph is being changed. So there are also many more histogram plots are there. 3D histogram is there also. Hist 3D. 10 into this is this. So here what I am doing, I am creating the D inside the command. See, right? So this is the 3D histogram also. Next, let us do radial plots and bar plots. For more charts, I can tell you in the console, go to console, write help bar. You are getting this help browser window. So here this is the bar graph. but you will be getting, these are the examples given. Means the keyword is BAR. For the vertical plotting of the bar graphs, it is BAR, and for the horizontal plotting, it is BARH. What you can do? This is the code. Set current figure 0 means the current figure number is 0. Y is equal to 1 minus 3 comma 5. And then bar y comma 0.5 comma yellow. Yellow is the color given to the bars, and y is being plotted with the width of 0.5. So this is the bar graph. Right? So here if we change this width 0.2, see the width of these bars will be reduced. So you can reduce accordingly. Then next, stacked bar is there.
मैम जैसे ये सारी चीजें मैथमेटिक्स से रिलेटेड हैं और सी अगर बिलोंग टू इलेक्ट्रिकल ब्रांच, तो ऐसा कुछ नहीं होता है जैसे अगर हम अपनी फिजिक्स से रिलेटेड कोई ग्राफ बनाना चाहें कि हमें लाइनें मिल जाएंगी ये टाइप में, हमें ये लाइक हमारा
इलेक्ट्रिकल में कैसे ग्राफ्स होते हैं?
जैसे आपका हमें रेक्टिफायर है, उसकी आउटपुट देखनी है,
साइन वेव आएगी, उसमें प्लॉट एक्स वाई होगा, साइन वाई होगा, यस। और
तो मैं वो ग्राफ अपलोड कर सकते हैं या पूरा रेक्टिफायर अगर बनाना चाहें डायोड ये लगा के?
okay, similar to Simulink in MATLAB, there is also a provision here that is called as, let me tell you, the participant here is asking about, means he is from the electrical branch and he want to know if you want to make a rectifier in SCILAB. As we do in MATLAB, we are doing in Simulink. So in SCILAB, we are doing in the XCOS. There is a tab XCOS. Let me show you. This is the XCOS, means the various blocks are available. Similarly, like MATLAB, you are getting these blocks. Commonly used blocks are there: continuous, time, discontinuous, lookup. These electrical tab is also there, so you can get all these blocks, put it in a separate window, and then make the connections accordingly as we do in the Simulink and MATLAB. I think you must have done in Simulink also. No, you haven't done. Okay. So these are the various, means earlier also I have given a lecture on these XCOS and the introduction to the SCILAB. So in that lecture I have given the introduction of this XCOS, means how to use it, and these blocks are available. And also one thing I want to tell, means there in MATLAB there is a image processing module is there, signal processing module, communication module is there. So all these modules are there in the SCILAB, but what you have to do, you have to go to this atoms site. So for that, internet connection is required, right? Go to this atoms. This is in the, I think it will be visible to these remote centers also. On the tab side, there is a written atoms. So by clicking on these atoms, all these modules which will be there, optimization, signal processing, then communication, image processing, all these modules, whichever module you want to download, you can click on it and then download. In MATLAB, what is there? All these modules are available in the MATLAB. We have to download them, right? But here, whatever module we want to download, we can download it. We can also change the source code also according to our application. Get it uploaded on the site also, so that others can also use your module. If you have given any modification in it, any improvement is there, you have given in that code also, right? So it is the provision for all these users. So I was telling you about the bar graphs. This was the simplest graph I told you. Then this is stacked graph. In this stacked graph, what you are doing? You are plotting the graph in the stacks. X equal to, you are creating the x variable, y variable, and then using the bar x comma y. Similarly, width can also be provided here also. This is the code. See. So only the keyword you must know the keyword of each and every graph. You want to use bar, histogram, plot 2D, plot 3D, mesh, surfing. So all these keywords are there similar to the MATLAB. So this type of graph is also available at the using the keyword stat. That's why I was discussing about it. This is stat. Just write bar x comma y comma stat. Right? X is 1, 2, 5 means at the places 1, 2, 3, 4 left flank and then 5th place. And these are the stacks 1, 4, 7, 2, 5, 8 and 3, 6, 9. Accordingly, this will be Y1, Y2, Y3. Means at the first place you are getting the 1, 2 and 3. This is same. Just you are giving the width point to bar x comma y comma point 2 comma green. You are also giving the colors option. So this is about the bar. Now going towards the radial. Actually we are getting short of the time, so that's why I am just showing you all these. Next is the radial. If I can open it. See, this is the contour graph using the command contour. CONTOUR. X comma y comma z comma 10. 10 means the how many curves you want to be there in the graph. So this is the graph you will be getting. Right? So what I did, x declared y, then mesh is there, z is equal to this, then contour x comma y comma z comma 10. Right? So then this is handle is being created, a is equal to GCA. So here you can see, right? So next a dot iso view. So some view is there, means in which view you want to see the graph. Next you can see radial plot. I think it is left. Everything we have covered. This is also a contour graph like this. Means the basic thing is same. You just have to have the knowledge of the keywords which are to be used for the particular graphs you want to plot. contour T comma T comma my surface. My surface now here C. The earlier which I showed you was the this one. Z is declared as x square plus y square, and in the contour command you wrote x comma y comma z comma 10. Now here in this you declared a function z is equal to this, and then used my surface. Here the name of the function you have written. And then 10. Rest is creating these x set contour again T10, and then plot 3D is also there. So all these keywords are there in the. To have a more look on this, you can type in the help. You can go to the graphics. All these commands are there as they are in the MATLAB. Okay, let us do the radial, which is being left. CLC here. Then theta is equal to 0:0.01 is to 2 into 5. Now one thing I want to tell, in MATLAB what we were doing, we were using these constants pi, imaginary function I, E as it is. Now in SCILAB these special constants have to be used by using the percentage pi, right? Now this pi or the I variable, if I am using percentage I, means now percentage I is a real imaginary part. Now I can use I somewhere else also, but in MATLAB this is not there. If I am using I as a imaginary part, then I can't use I as something else. Or pi, I can give the name of the variable as pi also. So it will be taken as a variable. When I am writing percentage pi, then it will be taken as a special constant. A is equal to 1.7, R is equal to, or R1 is equal to A square into cos of 3 theta. R2 is equal to A square into cos of 4 theta. Then polar plot. For the polar, you have to write polar plot theta comma R1 2 comma 2. Let us see. See, this is the polar plot, right? Similarly, I can write polar plot theta R2. In the same plot, I am writing R2, the different dimensions. See, right? This is theta R1 and R2 plotted in this polar. Yeah. I think this is enough for today. Any doubt up till now? Remote centers? Okay. So any, yeah. Pardon? किसके बारे में? Okay. Means you want to know about the SCILAB commands that are being used in MATLAB, or what do you want? As such, no booklet is there. I can provide you with the material, the soft copy. You are from which branch? Okay. Then you must be feeling familiar with all these MATLABs. And go to the help. Go to the help. You can have all the commands in there. Go to the help. In MATLAB also, in SCILAB also. Go to the help. So for the researchers, I think SCILAB is the best option, because in MATLAB there comes the problem of pirated version problem is there. Yes, for that you must know that which commands are available in the MATLAB. So for that means help is there. That you must have a knowledge about each and every command, whatever is there. Means nowadays internet is there, so many books are also available. So I think there is not any issue regarding this. What you are asking means what command we want to use. Actually, here the participant is asking that what command is we have to use. We should also have a knowledge about all the commands which are there in the software. So for that, I can suggest you can go to the help in the MATLAB or SCILAB also. I'll say you prefer SCILAB only. It is means freely available, saves in less space. You can also modify the codes. Whatever module you want to use, you can download at any time. Not so bulky as MATLAB is. So today we just discussed. Yes.
जी मैम।
Yes.
मैम जैसा कि मैटलैब में हम लोग कुछ कुछ स्पेशल फंक्शंस होते हैं, जस्ट लाइक द ईसीजी वेव शेप और द ईएमजी वेव शेप और समथिंग एल्स, तो क्या इसमें भी हम लोग साइलैब में स्पेशल फंक्शन को कॉल जो कर सकते हैं?
In MATLAB there is a function ECG wave.
Yes.
In which toolbox?
मैम अगर हम लोग सीधा सीधा अगर इसमें ये कि मैटलैब में कमांड लिखते हैं ईसीजी वेव, तो वो इसी वेव शेप आती है हमारे पास में।
Okay.
तो क्या इसी टाइप के फंक्शन इधर भी हैं क्या?
No, in SCILAB it is not there. According to my knowledge, it is not there in SCILAB. But as I earlier told, the developments are being made in the SCILAB also. So maybe in the future to come, you will be able to see this also.
Okay, ma'am. Thank you.
So from the remote centers, any doubts from any participant?
Ma'am, in which slash are used? Ma'am, this is for not working, ma'am, line.
Pardon?
मैम स्लैश मैम इसमें यूज किया है मैम, ये मैम किस लिए यूज किया है मैम?
कौन सा?
स्लैश मैम कमांड यूज की है मैम, ये किस लिए यूज किया है मैम? हाँ जी मैम।
Slash command you are saying. So double slashes are being used for commenting the any line in the SCILAB. In the MATLAB, what you are using? Percentage.
Okay मैम।
So in SCILAB, you are using double slashes for commenting any line.
Okay मैम।
Any other participant? Okay, then I suppose that today's session is understood by each and every participant. So with that note, I end this session. In case of any query in future also, you can contact me. Right? Thank you so much.